All right, so we're picking up with question 4 here, where I want you to find the derivative of sine inverse of x. And then, of course, we're going to extend that to the other inverse trig functions as well. Well, one thing I want to caution you on, right, is that sine inverse of x, okay, is not the same thing as sine of x all raised to the -1. Okay, the inverse, the exponent for the inverse does not work the same way as any other exponent does. Okay, which means it is also not the same thing as the reciprocal, right? 1 over sine of x. You cannot write it like that. And which means it is not the same thing as cosecant of x. So please understand that this little -1 here is not technically an exponent. It represents the inverse, okay? And so I will say that because of that common misconception, or I guess because the AP exam doesn't want you to make that mistake, on the AP exam, okay, sine inverse of x, they use a notation that looks like this, arc sine of x. And they would do that for any other inverse trig function as well. They would put that arc in front of it. So if you ever see that is their notation for the inverse, and they're using that so that you don't get the whole idea of a -1 exponent confused. Okay? All right, so if sine inverse of x is not the same thing as raising it to the -1 or moving it to the bottom, etc., then how on earth can we take the derivative of y equals sine inverse of x? Okay, well, somehow we need to get rid of sine inverse. If we can get rid of sine inverse, then maybe we can take the derivative, okay? All right, I don't know how much you remember about solving trig equations, all right, but if you want to, all right, let's say, let me see, when did it really come up? Okay, let's say that you had, I don't know, sine of x equals a half, okay? Technically, right, that's on the unit circle, and we would say, okay, where, what angle does sine equal a half, all right? But technically, what you're doing to solve that problem, what you're doing to get x by itself, is you're taking the sine inverse, that's hard to put it on the side, of both sides. Okay, so if you were to use your calculator, if you wanted to solve for x, you would have to use the sine inverse button. Sine inverse of 1/2 would tell me what x was equal to. Okay, and so ideally what happens is sine inverse and sine cancel each other out, because that's exactly what inverses do. They cancel each other out. All right, so with that in mind, we're going to use that idea over here. I want to get rid of sine inverse on the right, and hopefully if I get rid of it, it won't show up somewhere else. Okay, so to do that, I'm going to take the sine of both sides. I'm going to take the sine of both sides. And when I do that, sine and sine inverse cancel, or at least on that side, all right? And I am left with sine of y equals x. Now, why is that helpful? Well, because now I don't have an inverse in my problem anymore, and I have something that I can actually take the derivative of. I'm just going to have to make sure I do it using implicit differentiation, because when I take the derivative of a trig function with a y in it, I'm going to have to use implicit differentiation. Okay, so that's exactly what I'm going to do. I'm going to take the derivative of sine of y, which gives me cosine of y, but again, I need to multiply that whole thing by dy over dx, because I'm taking the derivative with respect to x. All right, and then on the right, I just get a 1. All right, so I can quickly finish that. All right, by writing 1 over cosine of y. I guess technically I could even change that to secant of y, but I don't want to leave a y in it. Let's put all x's back in it. Okay, let's put all x's back in it. Like I was doing with the other problems. All right, well, do I have something, do I know what y is equal to? Okay, yes, I do. Y is equal to sine inverse of x. So I can plug that in for y. I know it looks kind of crazy, all right? And so now dy over dx equals this fraction. Well, that does look a little crazy. And it doesn't really help me if I wanted to find the derivative at a point. So the cool thing with trig is that you can actually use trig, use right triangle trig and the Pythagorean theorem to find algebraic expressions instead of trig expressions. Okay? So let's step back for a second, all right? And let's make an angle in quadrant 1, okay? So I'm just gonna make an angle, all right? And I'm gonna call it y. And the reason I'm doing that is because I know that sine of y equals x, okay? And that's enough information to turn this thing into a right triangle and fill in the values of the sides, okay? Because if you remember your right triangle trig, sine of an angle is equal to opposite over hypotenuse, and I can make x a fraction by putting it over 1. So that means x is the opposite of my angle y, and 1 is the hypotenuse. And then I can use the Pythagorean theorem to find the missing side here, okay? So let's see. To find one of the sides, if you know the hypotenuse, it's always the square root of the hypotenuse squared minus the other side squared. Okay, you can work the Pythagorean theorem out on the side if you want. Okay, now let's go back to our derivative. All right, remember we said dy over dx was equal to 1 over cosine of y. Well, I'm going to leave it in that form because my angle is y. All right, so now using this picture, what is cosine of y? Remember, cosine is adjacent over hypotenuse. So the bottom of this fraction becomes the square root of 1 minus x squared over 1, which I don't need. You can write it, but it still simplifies to just the square root of 1 minus x squared. Okay? So what have we done? What have we just done? A little bit of epiphany here, or bring it all together. We have just taken the derivative with respect to x of sine inverse of x. That's what we have just done. And the answer is 1 over the square root of 1 minus x squared. Okay? And luckily, you never have to recreate that process again if you don't want to, okay? As long as you memorize, right? Just like you've had to memorize your other trig derivatives, okay? You'll want to memorize that the derivative of sine inverse of x is 1 over the square root of 1 minus x squared, okay? All right, now, what I want us to do, what I want you to do, is do the other 5 inverse trig functions, okay? You're going to do the other 5 inverse trig functions, and then I want you to see if you notice any patterns, all right? Also along the way, make sure that you are keeping track of your actual derivatives so that you can maybe rewrite them all in one location later so that you can keep that with the other ones that hopefully you're reviewing regularly, okay? All right, so I think I'm going to stop the video here because I actually would like you to try these on your own, but I will record a third video that has all of the solutions worked out.